Hello lads and lasses. Welcome to Malfa Data's SAT/PSAT tutorials. In this video, I'll be going over domain 1, which is Algebra. You can type in a link at the top of the screen for the slides, but I'll also leave it in the description. Real quick, there are also QR codes to different resources you can use. Of course, the questions and answer key are on the left. There's also a link to the College Board Desmos, which is the specific version you can use on the SAT, and I have this pulled up on the right here. And there's also some notes that I typed up. Let's go ahead and get started. These are the topics that we'll be going over. If you were in person, this is also how the slides would work. I would go through certain questions, and any marked with a cow would be ones you can try out yourself. Since this is online, I'll obviously be going through every single question. Feel free to follow along or try some of them out on your own. There's also this form that you would fill out, but once again, I'll go through all of them anyways, so you don't need to fill this out at all. Here we go with our first topic and question. They give us this equation here and ask us to find the value of t. Of course, you could solve this by hand by expanding it all out and then getting all the t's on one side, but why do all that when we have Desmos? So the first thing you should know is that you can just replace the t's with an x when you type it in Desmos, because they don't use x anywhere else in the equation, so it's completely fine to do that. And this is also my personal preference, but everything on the left side of the equation, I'm going to type in this first line right here, and then everything on the right side of the equation, I'm going to type in this second line. So let's go ahead and do that. Alright, so I went ahead and typed everything on the left side of the equation and replaced the t's with an x. And now to type the right side, you can't just type a number, but you could just type y equals that number, and you get your line. Now in any question, when they ask you to find a solution, when you're looking at the graph, you're just trying to see where those two lines intersect. So if we zoom out real quick, we notice it intersects right here. And since our x would technically be our t, we're trying to find the x value, and here that would be negative 22. So that means our answer would be negative 22. Slide number 7. They give us this equation and ask us the value of x plus 6 is between which of the following pairs of values. First up, we need to solve for x, and we can do that by once again plugging our equation into Desmos. I want to plug everything on the left side of the equal sign into the top line, and everything on the right side of the equal sign into the second line. So let's go ahead and do that. I went ahead and typed in that equation in those two lines, and once again our answer is going to be where the two lines intersect. So that's going to be at this point right here, and our x value will be negative 6. However, we're not done just yet. They're asking us for x plus 6, so we would actually need to do negative 6 plus 6, which means that the value would be 0. So 0 is between which two numbers? Is it between negative 7 and negative 3? No. Is it between negative 2 and 2? Yes. So that means our answer will be B. Slide number 8. They're asking us how many solutions does this equation have? Based on our last two questions, you should already know that we have a solution whenever the two lines intersect. However, it can be a little more than just that. So if you go ahead and look at the notes, you'll see right here, whenever there's infinitely many solutions, it looks like those two lines are overlapping. Whenever there's no solutions, of course, those two lines will be parallel and never intersect. And whenever there's one solution, which is the case in our past two questions, those two lines intersect at one point. So let's go ahead and plug this equation into Desmos. Everything on the left side of the equation into the first line, and everything on the right side of the equation into the second line. Let me go ahead and do that. Alright, I went ahead and plugged in our equation, and you notice here, it looks like there's only one line. Now an easy way to tell if there's actually two lines, and they're just overlapping, is that I like to click between the two lines. So here you can tell, here's our blue one, and then you can tell here's our green one, and they just happen to be on top of each other. So there you go. Whenever you have two overlapping lines, that means you have infinitely many solutions, so that means our answer will be C. Slide number 9. They give us this equation and tell us that there's also this letter P that represents some number. They also tell us that the equation has no solution, and we want to find the value of p. First up, no solution, which means that these two lines should never intersect. So real quick, let's go ahead and just plug that equation into Desmos. Everything on the left side into the first line, and everything on the right into the second line. And once again, since we have a number, you would just type in y equals 84. So I plugged in everything on the left side of the equation, and they're telling me to add this slider p. And you do want to do that. Now you can do that by just clicking on this blue button, or you could also just click enter, and it would do it automatically. Now let's go ahead and type in y equals 84, and now we have our two equations. Real quick, if we were to look at our graph, you'll notice that the two lines do intersect, which means the equation does have a solution. Now we need to change the value of p and mess it around a little bit until the two lines don't intersect. Now you don't need to be using this slider at all, and you also don't need to be guessing, because they give you answer choices. So guys, just plug in those answer choices. First up, let's plug in A, where p would be equal to 0, and you can tell that has a solution, so that can't be our answer. Now let's plug in B, 1 over 7. Okay. And now you notice that these two lines are parallel, they never touch, which means our answer would be B. Real quick, let me just plug in the other two, 4 over 3. The two lines, oh wait, hold on, do intersect, and then p equals 4, and the two lines would intersect. Once again, our answer would be B. Slide number 10. They give us this equation and tell us that this letter k represents some number. They also tell us that the equation has no solution and want us to find the value of k. This is pretty much just like the last question, except this time we don't get answer choices. You should also notice that our equation doesn't look too pretty. There's this really fat fraction right there. So in this case, it would probably be best to solve it by hand. If you plugged it into Desmos, you would have to mess around with the slider a lot, because most likely, it's gonna end up with another ugly fraction. If you go ahead and look at our notes, you'll notice that whenever there's no solutions, they have the same slope but different y-intercept. In this case, what we want to focus on is that they have the same slope. Of course, these are all linear equations, and the formula for a line is y equals mx plus b, where the number before x is the slope. That means on the right here, the slope would be 48 over 17, and on the left, we would actually need to distribute the 3 first, so our slope would actually be 3k. Wait, I messed up, hold on. I forgot to multiply the 13 by 3. My bad, guys. I can't math. Alright, once again, whenever you have two parallel lines, they have the same slope. So what can we do? We can set the slope of these two lines equal to each other. 3k is equal to 48 over 17. And now we just need to solve for k. Of course, you would just divide by 3. And now this part, we can't put in Desmos. So you would do, where's the fraction button at? Oh, here it is. 48 over 17. And then you want to put this entire thing in parentheses. And then click the fraction button again, put that over 3. And you end up with this really nasty decimal. I mean, imagine trying to put in a slider, bro. Like, how would you even get to that? Wait, why is the slider not even working? Oh, there we go. Like, imagine trying to slide to 0.94117. Like, no one's trying to do all that. That's why you solve it by hand. And of course, you can just click this fraction button, and it would turn out to be 16 over 17. Wait a minute, hold on. Of course, you could always plug this equation back into Desmos and check if the two lines don't intersect. So real quick, 3 times, and instead of k, we're going to put 16 over 17, x plus 13, and then in our second line, 48 over 17x plus 36. And you notice that yes, these two lines are parallel, so we did get the right answer for k. Slide number 11, they give us an equation, and they tell us that these two letters, k and n, represent a number, and the equation has no solution. They're asking us to find the value of k. Of course, we're pretty used to solving for just one variable, solve for x. This time we have two variables. What are we gonna do? Of course, it don't matter because we already know that whenever an equation has no solution, that means they have the same slope. Yes, they have a different y-intercept, but whenever we're trying to solve for it by hand, we don't need to worry about the y-intercept. All we need to do is set the slopes equal to each other. We have a linear equation, which means the equation of a line is y equals mx plus b, where the number before x is our slope. That means that on our right side, negative 28 over 15 is our slope, and then on the left side, we would need to distribute the 2, and we would get 2k is equal to our slope. So would you look at that? All you need to do is set the two slopes equal to each other. Don't even worry about the end, alright? That is a distractor. It does not matter at all. Now let's go ahead and solve for k by dividing the entire thing by 2. We can put this in decimals. First up, you want to put a fraction and negative 28 over 15. Put this entire thing in parentheses and click the fraction button again and put that over 2. And we get that our answer would be negative 0.93 repeating. Once again, imagine trying to put that into a slider. Wait, I'm not doing that again. Okay, anyways, you can click this fraction button on the left here, and you would get that our answer would be negative 14 over 15. Now we're moving on into our next topic. Let's get started with slide number 13. Whenever you have these word problems, the first thing you want to do is identify what is the x value and what is the y value. Because in this equation, you can tell they don't use x and y, they use q and p because they just want to be extra for no reason. Now there is an extremely easy way to tell what's your x and what's your y. And of course I wrote it on the notes. So right here under linear functions, whenever it says output is a function of input, it's the same thing as saying y is a function of x. So we'll always follow this format. Y is a function of x. Let's look at our question here. Q is a function of p. So here, q would be our y, and then p would be our x. Q is a function of p, y is a function of x. Do y'all see the similarity I'm trying to get here? That means that down here, when they say the demand was 20,000 units, when the selling price was $40, they're saying that the y is 20,000 when the x was 40. Let's go ahead and put that in the table. And same thing here. The demand, the y, was 15,000 when the selling price, x, was 60. Now they're asking us for the demand, or the y value, when the selling price, or x, is 55. So here x is equal to 55, and we're trying to find what that y value would be. Now you could solve for the equation of a line y equals mx plus b by hand using delta y over delta x or whatever. But of course, why do that when you got Desmos? Come on guys. I did write these instructions in our notes as well for how to do that. So let me go ahead and walk you through. First up, you want to click this plus sign right here and add a table. Then we already sorted all of our points into a table. So now we just need to copy those over. 40, 20,000, 60, 15,000. And obviously you wouldn't put 55 there because what would you put in the y value? Anyways, now we want to do linear regression to get our line, or our equation I guess. Now there's two ways you could do this. The first way is by writing in this regression equation and actually explain why it works up here. Normally your equation would be y equals mx plus b, but whenever you do it in Desmos, you want to put a 1 after every y, a 1 after every x, and change the equal sign to a tilde. So that's basically what I did down here. But of course, if you don't want to memorize that equation, you don't have to. You can just click this little line with dots up here. It says add regression. You can go ahead and do that. And obviously we're doing linear regression because they tell us it's a linear function. Wow, beautiful. Alright, here's the equation of our line. And I'm pretty sure you know what to do from here. Let's just go ahead and put in 55 instead of x. So negative 250 times 55 plus 30,000. And we get our y value would be 16,250. That means our answer will be A. Slide number 14. Once again, we have a word problem. So let's find what our x and y values are. In this case, they actually give us equations in our answer choices. So it's going to be pretty easy to tell what our x and y's are. Of course, you're pretty used to seeing f of x being y. And same thing here. f of t is going to be our y value, and then t will be our x value. So instead of f of x, we had f of t. Same difference. Alright, so we know what letters our y and x values are. Now let's see what they actually represent. We note that f is going to be the production in millions of barrels, and then t is going to be the years after the year 2000. Let's go ahead and plug in the info they give us into a table. Here it says we have 4 million barrels, but hold on, we're not going to write in 4 million as our y value. Because remember, our production is in millions of barrels. They already account for that millions in the unit itself. So you would only put a 4. You know, when I think of this, I just think that, oh, millions of barrels and millions of barrels, they cancel out, leaving you with the number 4. Okay, that's what I do. Same thing here. 1.9 million barrels cancels out with the million barrels. I'm gonna just write that down too. I kind of skipped ahead, my bad. Alright, and then it says that the year is 2000. But remember, we're not gonna write in 2000 in our x value either. It's gonna be the years after 2000. How many years is 2000 after 2000? I mean, the answer is just 0. And then here, 2013. 2013 is 13 years after 2000. Alright, now that we have our table with our data points, let's go ahead and insert a table into Desmos. So once again, click this plus sign right here. I don't know why these two are overlapped, that's kind of weird. Let's go ahead and add that table and put in our points. Oops, what the heck? Alright, and then click on this add regression button right here. We want linear regression because once again, we have a linear function. And we also have our equation down here. Now all of our answer choices are in fraction, so the best way to do this is just plug in the fraction we have in our answer choice and see if it matches the decimal we have. So what I'm trying to say is 21 over 130, that is 0.161, and that does match this right here. Of course, this is negative, so it can't be A or B because those are positive. And then that means our answer would be C, because once again our fraction is 21 over 130, and we do want that negative in front. Slide number 15. Here they give us the equation, and they also tell us what the y and x mean. Thank the Lord, we don't need to find it out ourselves. We know that y is going to be the average price per gallon, and x is going to be the number of months after September 1st. Now they're asking us, what does 2.74 mean in this equation? Right now, this equation looks a little funky, but at the end of the day, it's just the equation of a line. We can rewrite it in slope-intercept form, y equals mx plus b. I went ahead and moved the equation around a little bit, and now you can clearly tell that 2.74 is our b value, or y-intercept. And in case you forgot what a y-intercept was, you don't even have to worry because of course I wrote it on the notes. It's right here, and you'll see that y-intercept is going to be the starting point or the initial value. But really, in the most general terms possible, it's the value of y when x is equal to 0. We can go ahead and plug this in, but instead of saying y, let's say the average price per gallon, and instead of saying x, let's say months after September. First up, we know that it has to start off with the average price per gallon, because once again, the value of y, the average price per gallon. So we know it's not going to be some monthly decrease or difference in anything. Now, we have to choose, is it going to be on September 1st or December 1st? Normally you would think, oh, it's 0 months after September 1st because x is equal to 0. So that means that obviously our starting date would be September 1st. But this question is a little bit tricky. You see, the problem is you have this -3 right here. And if you remember anything about transformations, that means your function is shifted right 3. So technically, instead of your initial x value being at 0, you would add 3, and your initial x value would actually be at 3. So really, instead of being on September 1st, it would be 3 months after September 1st, which means our answer would actually be D, because 3 months after September 1st is December. Alright, I know that was probably a little bit confusing when I explained it in words, so let me show you what it would look like on a graph. Let me say this again. X is the number of months after September 1st. So, technically, if we wanted to find the average price per gallon on September 1st, like they ask us in C, we would set x equal to 0. So here I'm gonna just type in f of 0. And here's the thing. The answer would be 3.31, not the 2.74 we have. Oh shoot. But if we were to put in December 1st, which is 3 months after September 1st, or x is equal to 3, f of 3, we would get that our answer is, you guessed it, 2.74. So yes, this question is a little bit tricky just because they added this extra -3 right here. So that's what I recommend you do sometimes. You might want to just plug in that equation into Desmos and see if the numbers match up. Slide number 16, they give us this equation. Let me quickly rewrite it in slope-intercept form, y equals mx plus b. There we go, I just moved the 2w to the front and also swapped x for w and y for l. They also tell us what x and y mean. We note that l, or y, is the length in centimeters, and we also know that w, or x, is the weight of the object. And they ask us, what is the meaning of 2 in this context, in this equation? Here you can see 2 is the number before our x, which means it's the slope. Now we know how to solve for and use slope, but what does slope actually mean? Well, fear not, because I did write it down right over here. Your slope is the rate of change, or really more generally, how much y increases or decreases each time x increases by 1. Of course, y would be increasing if your slope is positive, and it would be decreasing if your slope was negative. In this question, our slope is positive, so we're going to be using the increasing part. And let's also substitute y and x for the length and width. I'm gonna just quickly type it out. Alright, so I went ahead and plugged it in. Instead of saying the increase of y as the x increases by 1, we would have the increase in the length of the spring as the weight of the object increases by 1. Now let's see which of our answer choices match that. It's not just gonna be the length or the weight by itself, it's gonna have the word increase first. And also not gonna be the increase of the weight, it's gonna be the increase in the length as the weight increases by 1. Right, now it's not in the same order, but still has the same general idea. And of course, increase in length does come first, and that's what's most important, which means our answer is D. Now we're moving on into our next topic. Let's get started with slide number 18. Here they give us the equation of line P, and they tell us line R is perpendicular to line P. Then they ask us to find the slope of line R. First up, we need to find the slope of line P. Usually, we're used to seeing equations in slope-intercept form, where the slope is before the x. However, in this question, the equation they give us is not in slope-intercept form, and you can tell because the x is on the other side of the equal sign. All that does is really just add 2 more steps to finding our slope. I mean, all we have to do is make this equation look like this equation. So basically, we just need to move x to the other side and then get y by itself. So first up, let's move x to the other side by subtracting 8x from both sides. Alright, and then we need to get y by itself, so we need to divide both sides by 4. And we get that the equation of line P in slope-intercept form would be y equals negative 2x plus 3 over 2. And of course, our slope would be negative 2. Real quick, I just showed you the algebra way to do it, but of course, there is a little shortcut to solving it. I wrote it right here in the notes. Whenever you have an equation in the form of ax plus by equals c, all you have to do is put a negative sign in front of a and divide it by b. But the important thing to notice is what a and b are. A is the number in front of x, and b is the number in front of y. And I'm pointing this out because in this question, the b value actually comes first. So be careful to notice that. Alright, real quick, negative a, so negative, and the number in front of our x is 8, divided by b, which is the number in front of y. Negative 8 divided by 4, that's negative 2, same thing we got. Alright, now that we got that out of the way, we note that line R is perpendicular to line P. If you don't remember what perpendicular means, well, fear not, because it's right here. It means you have the opposite and reciprocal slope. First up, opposite just means change the sign, and the reciprocal means swap the top and bottom of the fraction. Alright, I'm running out of space, so I'm going to swap to a different color. Right now our slope is -2, but we want it to be the opposite sign, so that's going to be +2. And you should also remember, whenever you have a whole number, technically it is a fraction, it will just be over 1. So 2 is equal to 2 over 1. Alright, now we're going to take the reciprocal of this, so all we need to do is swap the top and the bottom. So now, instead of the 1 being on the bottom, it will be on the top, and instead of the 2 being on the top, it would be on the bottom. So the perpendicular slope of -2 would be 1/2, and that means the slope of line R would be 1/2. Slide number 19. Here they tell us that line L is perpendicular to a line with the equation x equals 2, and they want us to find the slope of line L. First up, we need to find the slope of this equation right here, x equals 2. Let me go ahead and plug this into Desmos just to show you, but it's gonna be a vertical line. And whenever you have a vertical line, the slope is going to be undefined. And the reason for this is because slope is change in y over change in x. Technically, the change in y is like what, infinity? And then the change in x is 0. Anything divided by 0 is undefined. Now remember, to get a perpendicular line, you're going to take the opposite and reciprocal slope. So you would slap a negative sign in front of this, and then swap the top and the bottom. So now you would have -0 over infinity. Whenever you have 0 divided by anything, it's always going to be 0. So really this would just be 0, or I guess you could say -0, but is that not just the same thing? Anyways, that means our answer will be A. Also real quick, a perpendicular line means it intersects at a 90-degree angle. What intersects a vertical line at a 90-degree angle? Well, if you guessed the horizontal line, you'd be correct. So that would just be a y equals line. And whenever you have a y equals line, the slope is, you guessed it, 0. And the reason for this is because, what's the change in y? Well, technically it would be 0. And then what's the change in x? It would be infinity. Holy crap, these two are the exact same. Slide number 20. Here we have line L, which passes through the point 0, 0. And it's also parallel to the line in this equation, y equals 8x plus 2. And remember, parallel lines means they have the same slope. They're telling us line L also passes through the second point, and they want us to find the y value at that point. First up, we need to actually find the equation of line L. We know we can write a line in the form of y equals mx plus b, where m is the slope and b is the y-intercept. We already know that the slope is going to be the exact same as the slope in this equation right here, because they're parallel, which means the slope will be 8. Let's go ahead and substitute m in for 8. Wait, it's the other way around, 8 in for m. Okay, whatever. Next up, we need to get b out of here. Remember, your y-intercept is the value of y when x is equal to 0. They actually give us that point. When x is equal to 0, y is also equal to 0. So that means our y-intercept would be 0. So there's the equation of our line. It's just y equals 8 times x. Normally, you know, I would put this in Desmos, but come on guys, it's not that bad. Let's just take this 3, plug it in here. 8 times 3 is equal to 24. So 24 will be the value of D. Now we're moving on into our next topic, and let's get started with slide number 22. Here they give us two equations, or a system of equations, and you can tell that I separated the two because one is boxed and the other isn't. They tell us that this system has no solution and they want us to find the value of P. Now once again, just like before, whenever something has no solution, that means that the two lines won't intersect. It's the exact same thing here. These two should not intersect. Now let's go ahead and plug this into Desmos. Normally I would say everything on the left side of the equal sign in one line, and everything on the right side of the equal sign in another line. But in this question, since we already have two whole equations, they can each get their own line. Alright, just like before, they're asking us to add a slider. Let's go ahead and do that. Now we want to change the value of p until these two lines don't touch at all. Once again, if you zoom out and just click on a line, it will instantly show up a point where the two lines intersect. So let's change this to 5, click on the line, hold on, there's still a point. I'm gonna change it to 6, click on the line, and you can see these two lines don't intersect or touch at all anymore. They're parallel. That means that p will be equal to 6. Now you might be asking, when do I know if I need to solve it by hand or if I can put it in Desmos? And my answer to that is A. If the fraction is really ugly, you probably want to solve it by hand. In this question, all the denominators are really small and they all also have a common denominator. You could technically multiply the entire thing by 12 and get rid of all the fractions. Another thing is, this is a system of equations, so it's less likely for it to be as hard as the earlier one we had, where it was like 16 over 17. Slide number 23. Once again, we have a system of equations. We have t, which represents a number, and this system has no solution. They want us to find the value of t. Once again, let's just go ahead and plug these two equations into Desmos. And the reason we can do this is because A, it's a system. It's less likely for it to be a fraction or decimal answer, and B, this isn't really that bad. I mean, there's only one fraction, and really you could just multiply the thing by 2, so not that bad. There's our first equation in its own line, and I boxed it out so you could tell the difference. Here's our second equation. Alright, I went ahead and added our two equations. They're asking us to add a slider. Let's go ahead and do that. Now we just need to change the value of t until these two lines don't touch anymore. Also, I've just been like messing around, but it's kind of around this point right here. No, there's no way I just got it. Oh my goodness, I genuinely might just be the GOAT. Okay, I swear that was not on purpose. I might just be a legend. Alright, you can tell, but these two lines don't intersect. That means t is going to be equal to 8. But real quick, let's say t was equal to 7. Let's say I undershot it. Well, A, you can tell that's getting bigger over here. And then down here, of course, it intersects at this point. So once again, t is equal to 8. I might just be the GOAT. Slide number 24. Here they give us this equation. And they also give us our second equation right here. They tell us that this system has an infinite number of solutions. And they want us to find the value of A. Alright, so an infinite number of solutions. If we go ahead and look at our notes, you'll see that whenever you have infinitely many solutions, that means you have the same slope and y-intercept. So basically, you have two exact same equations that are in different fonts. So theoretically, let me say I gave you an equation that looked like this. 6x plus 7y is equal to 67. Wait, I'm so funny. Alright, and now let's make this a system by adding a second equation. 12x plus 14y is equal to 134. Now real quick, let's plug these two equations into Desmos. Alright, I went ahead and plugged in our two equations, and oh my goodness, they are overlapping. What does this mean? They have an infinite number of solutions. But how can this be? These two obviously don't look like the same equation. So how could it be possible that they're both the same? And of course, since you are all very smart lads and lasses, I'm sure you already noticed. But to go from this first equation to the second equation, all I did was multiply every single number by 2. So I did 6 times 2, 7 times 2, and 67 times 2. And you notice that it still gives you the exact same equation. You still get the exact same line, and you get infinitely many solutions. So what was the point of me giving you that random example? Well, you can apply that exact same logic to the question we have right here. What number do we multiply by to go from this first equation to the second equation? What do we multiply by? It's basically the exact same thing. We know in the example I gave you, I multiplied by 2. Now let's find out what they multiplied by in this question right here. The giveaway here is gonna be this. Y. Y is by itself. There's no number in front of y. But if we look at our first equation, there's a 1/3 in front of y. So basically, how do we make that 1/3 disappear? The answer is we multiplied by 3. Because 1/3 times 3 is just 1. So you'd be left with 1y. Alright, so let's multiply the entire top equation by 3 and see what we end up with. We would get 3 over 2x plus 1y plus 3 over 6, which is also just 1/2, but there's no point to simplify it. Alright, now let's check. Does this equation right here match this equation? Is there a number in front of x? Yes, there is. Is there only y by itself? Yes, it is. And is there only c by itself? Yes, it is. Or I guess I should have been saying yes, there is. Anyways, that doesn't matter. They ask us for the value of a, which is the number in front of x. So that means our answer will be 3 over 2. But of course, if that explanation was a little wonky to you, now we can go ahead and just plug this equation into Desmos and see if the two lines overlap. So here's our first equation. And here's the one that we solved for. Okay, I just realized I wrote a plus sign instead of an equals. But anyways, you notice that, oh my goodness, the two lines overlap because they are indeed the exact same. So once again, our answer would be the number in front of x, or 3 over 2. Slide number 25, they give us the system of equations, and they tell us xy is the solution to the system above, and they want the value of 3x plus 3y. Basically, we need to find a point where those two equations intersect, and then the x value and the y value of that, multiply those by 3, add them up, and we get our answer. So let's go ahead and plug these two equations into Desmos. Alright, so I went ahead and plugged in our two equations, and we get that they intersect at... So, you don't actually need to type these out yourself. Do you see this button right here? You can go ahead and just click that, and boom, it puts it in this little text box for you already. Now, all we have to do is multiply our x and our y by 3. So 3 times that, get rid of the comma, replace that with a plus sign, and then 3 times that. We get that our answer is -5. So that means our answer will be B. Slide number 26. They give us this system and tell us that the solution is at xy. Then they want us to find the value of x times y. So basically, find the x and y values at the point where they intersect and multiply them together. So let's go ahead and type our equations into Desmos. Alright, I went ahead and typed in our two equations. These two intersect at this point right here. And then we just need to multiply them together. So once again, I'm going to export these points and then just multiply them. And we get that our answer will be 1.8. Now we're moving on into our final topic. Let's get started with slide number 28. Here they give us two inequalities or a system of inequalities, and they ask us which of these points would be a solution to the system. First up, let's go ahead and type these two inequalities into Desmos. Now when you're typing an inequality sign, of course you should be able to see the arrow keys on your keyboard at the very bottom right above your spacebar. So here's the less than key right next to the letter M. And if you want to put that equal sign or that bar underneath, all you have to do is type an equal sign after that. Now if you don't want to do all of that, of course, there's this symbol right here in the keyboard section. And you can just click that. And same thing here, Y. And then you can click this button right here, -2x minus 1. Alright, now to solve inequalities, if we look at our notes, let's go ahead and scroll down. Okay, I completely forgot I had this section, but guess what guys, we didn't need this, alright? All of this is extra yap. This is complicated way. We don't need to do that. We can just plug in our systems like normal. Anyways, back to inequalities. Who cares about equations anymore? We went ahead and typed both our inequalities in. And now the solutions are in the area where both of the inequalities overlap. So, if we look at Desmos, our first inequality is this black region. And you notice that down here, it's only the black region. And then if you look at our second inequality, which is the red region, if you look up here, it's only the red region. But of course, if you go over here to the right, you notice that both the black and the red overlap. So in order for our point to be a solution to the system, it has to be in this area over here to the right where both of the inequalities overlap. So from here, all we gotta do is type in our points. So parentheses, -14, comma 0. What I like to do is right here it says label. I like to click label because it makes it easier to see the point. Alright, that's way away. That's definitely not over here on the right, so A can't be our answer. Now let's plug in B. Okay, well, that one's obvious. It's also not there. Now let's plug in C. Also not in there. And finally, let's plug in D. And oh my goodness, who would have guessed? It's in that region where both of them overlap. So that means our answer will be D. Slide number 29. They give us this inequality and ask us in which table do all of those coordinate pairs fall under the shaded region of the inequality. First up, let's plug the inequality into Desmos. Alright, so here's our inequality. And now, guess what we gotta do? Plug in each and every one of those points. How exciting. First up with A, let's plug in 320. And I like to label the point. And you notice that it's right on the line. Now here's the problem. Since this is a dotted line, this won't count as a solution. Now if this was a solid line and we had a less than or equal to symbol, and you can see it's a solid line, this would be a solution. But once again, it's only a dotted line, so that means 320 will not be a solution. So 320 wouldn't work. We also know that 324 wouldn't work because that's obviously just way above. I mean, if 320 is at borderline, 324 is just way above that. Alright, now if we look at B and C, our deciding factor is it gonna be 536 or 528? I'm gonna cast a guess, I'm gonna say it's 528. So let's go with that one first. 528. Let's label the point. And let's see, is it inside the shaded region? Oh my goodness, it is. I swear I did not look at the answer key, okay? I swear I did not. So that means our answer will be C. But just for funsies, let's check if 740 would work. Obviously, it should. And here it is. So all three of those points in table C fall under the shaded region. Slide number 30. Once again, they give us an inequality and they ask us in which table do each of the coordinate pairs fall inside the shaded region. In which table are all of the points solutions? Guys, you already know how to do this. It's just like the last question, and I don't feel like typing a bunch of points in. So I'm gonna just tell you real quick that the answer is D, and let's prove that by plugging this into Desmos. Alright, first up, here's our inequality. Now let's plug in all of our points. 326, oh my goodness, who would have guessed it's inside of the shaded region? Just barely, goodness. And you have 552, label that. And it should be inside of the region. And lastly, 891. And of course, inside of the shaded region. So these are our answer. Slide number 31. Here they give us this system of inequalities, and they ask us which of these inequalities in the answer choices would overlap the same region that the other two do. So basically, you know, in the past questions, we had our two inequalities and we wanted our points to be in the region where both of them overlap. Same thing here, but instead of having points in that shaded region, we want another shaded region in that shaded region. So basically, three shaded regions on top of each other. Alright, let's go ahead and just plug these inequalities in. Alright, so here are our two inequalities that they gave us. Now let's start plugging in our answer choices. Alright, so here's A, y is greater than 6. And you notice that right here, we have this tiny triangle where the top two inequalities overlap, but the third one doesn't. And we want to make sure that all three of them overlap. So A can't be our answer. Now let's plug in B. And you notice that this time, all three of them overlap this one triangle right here. This section right here has all three inequalities overlapping each other. B would be our answer. Real quick, let's plug in 5 over 2. And you notice that this time, the purple region has this extra white part right here that it's not shaded by the blue or green inequality. So that's extra stuff we don't want. And then 3 over 2, same thing, except this time we have even more white stuff. So A, there was not enough of this section up here, and then C and D, there was too much of this section down here. Once again, our answer is B. Alright, that concludes all the questions I have for Mu Alpha Theta's tutorials on Domain 1, Algebra. If you would like more practice on harder questions, please check out my SAT doc. And real quick, let me show you how to use it. So of course, you would want to click on the math section. and then you would want to click on the first domain, which is algebra. And just like in the slides, it's broken up by the different topics. So you have linear equations, one variable, linear functions, systems, and inequalities. Same thing per usual, I have the questions, the answer key, and I also have a video where I go through all of the questions. That's gonna be it. Good luck studying, and I'll see ya. Min out.